Help me! I'm falling up.
What? What we just heard might feel awkward. However, look at this weird shape I observed in National Science Center, Delhi. This double cone is apparently able to roll uphill the inclined rails without any external force. Surprised? How can something defy gravity? Well, it does not. It just appears that this double cone is rolling up against gravity. However, it is actually going down and is totally in sync with the law of gravitation. When I learnt about the concept of center of gravity, I knew it was actually coming down. I could even make this ball roll up. In this video, I will discuss the secret behind this double cone rolling uphill and why is it completely in sync with gravity. Because of this peculiar behavior, this instrument is also known as a mechanical paradox. We will first make our own mechanical paradox and then discuss how it works. Take two exactly same sized funnels or cones and join them together at their widest part using a tape to make our double cone shape. You can follow these steps to make the same at home using thick chart paper. Now we will make our inclined rails. For that we will place two pipes in a V shape. The open end of the V being slightly less than the width of the double cone. We will place something under the open ends of V to make it inclined. If we place anything over these inclined rails, that is supposed to roll down. Let's see what happens if we place a double cone on these inclined rails. Our shape rolls up. The science behind this experiment is based on the concept of center of mass and center of gravity. Every object has a theoretical point where the object's entire mass is said to be concentrated. This is called the center of mass. Center of mass of geometric shapes with uniform distribution of mass throughout their bodies lies in their geometric center. Sometimes the center of mass doesn't fall anywhere on the object. Instead, it lies outside the object. For example, the center of mass of a ring is located at its geometric center where there isn't any material. Center of gravity is again a theoretical point where gravity appears to act on an object or the point where the whole weight of the body is supposed to act. We know gravity is pulling downwards on everything. The center of gravity is the point over which the object can be perfectly balanced. The center of mass and the center of gravity are the same in a uniform gravitational field. So, on Earth, center of mass and center of gravity of objects will be the same as gravitational field is uniform at any point. However, in space, center of mass and center of gravity can be different. For example, the moon's center of mass is very close to its geometric center. If there were no other bodies of mass acting on the moon, then the center of gravity would be same as the center of mass. But its center of gravity is slightly displaced towards Earth because of the stronger gravitational force on that side of the moon. As this double cone is symmetric and uniform, the center of gravity lies in its center. The natural motion of objects depends on the center of gravity, which has a natural tendency to go down. This double cone also has the natural tendency to lower its center of gravity. Due to the shape of the double cone and the rails, when the cone sits in the open end, its center of gravity is actually lower than when it was sitting in the closed end despite it being inclined. Let's measure the same to confirm. At this position, we can mark its center point. And now again, when it has rolled up, we can see that this point has actually lowered. The distance of the center of gravity from the horizontal plane decreases as the double cone rises. So, the cone tends to fall in this gap to lower its center of gravity. That's how this rolling up the inclined rails is totally as per the law of gravitation. The same effect can be observed using a ball because when it rolls up the rails, the ball starts falling inside the gap to decrease its center of gravity. I have another ball with rugby kind of shape. You might have noticed something common in the kind of shape this double cone and the ball have. Both of these are wider at the center. You would not be able to roll these shapes up an inclined plane. It only works when we have V-shaped inclined rails. The inclined rails let these items fall into the gap to lower the center of gravity. If we place both ends of the rail on a level surface, we can control the direction of movement of the ball by slightly increasing the gap between the rails on that side. Left or right?
Left.
To my left. Now to my right. My dad told me how similar concept is used by CVT transmission used in certain vehicles to achieve variable speed. A belt rides in a groove between two cones on each pulley. The gap between cones of a pulley is increased or decreased to lower or raise the belt to make infinite number of gear ratios. Thank you for watching this video. If you like my videos, do share with friends, like and subscribe my channel.